February 27, 1917. Congress Heights, Washington, D.C. The air is freezing, but Val Browning is sweating. He stands in a muddy field, staring down the barrel of a heavy, water-cooled machine gun. Beside him stands his father, John Moses Browning, the most prolific gun designer in human history. But today, reputation means nothing. Facing them is a skeptical board of Army ordnance officers. They have heard promises before. They have seen guns jam, overheat, and explode. They are looking for reasons to say no, and the stakes couldn't be higher. Across the Atlantic, the Great War has been raging for 3 years. It is a war of attrition, defined by the relentless rhythm of the Maxim gun and the Vickers. The British have them. The Germans have them. The French have them. But the United States Army, they have almost nothing. If America enters this war, which seems inevitable with every passing day, its boys will be walking into a meat grinder armed with bolt-action rifles against industrial-scale slaughter. John Browning nods to his son. Val pulls the trigger. The gun erupts. It doesn't stop. It doesn't stutter. It doesn't jam. The belt of ammunition feeds through the receiver like water flowing downhill. 1 minute passes. Then 2, then 10. The water in the cooling jacket begins to boil, sending plumes of steam into the winter air, but the gun keeps firing. The pile of spent brass casings grows from a mound into a small mountain. The ordnance officers stop taking notes and simply stare. They are witnessing the birth of a legend, but they don't know the terrifying reality behind this demonstration. The United States military is catastrophically unprepared for modern warfare. They are years behind in technology, strategy, and production. This is the documented story of how John Moses Browning, working out of a small shop in Utah, solved an impossible engineering problem, humiliated the skeptics, and delivered the weapon that would break the stalemate of the Western Front. To understand the magnitude of the crisis in 1917, we have to look at the numbers. They are not just disappointing, they are terrifying. When the United States declared war on Germany in April 1917, the U.S. Army had roughly 670,000 men in total, including the National Guard. To arm this force, the inventory lists showed a pitiful collection of obsolete weaponry. The Army possessed exactly 282 Model 1904 Maxims. They had 158 Colt Browning Model 1895 potato diggers, a design nearly 20 years old. And they had 60-70 Benate Mercy machine rifles, a temperamental French design that was notorious for jamming if a speck of dust entered the action. That was it. Fewer than 200 machine guns for an entire army. Compare that to the enemy. By 1917, the German Imperial Army had deployed over 12,000 Maschinengewehr-Joades, the MG-08, on the Western Front alone. A single German regiment had more automatic firepower than entire American divisions. The MG-08 could fire 500 rounds per minute, hour after hour, creating a beaten zone of denial that no infantry charge could survive. The strategic vulnerability was absolute. General John J. Pershing, commander of the American Expeditionary Forces, sent an urgent cable to Washington. His assessment was blunt. Without modern machine guns, American soldiers would be little more than targets. He demanded a domestic supply chain immediately. But the American industrial base was asleep. There were no factories tooled up to build machine guns in the necessary volume. The tooling didn't exist. The gauges didn't exist. The skilled labor wasn't trained. The War Department's initial solution was humiliating. They bought French guns. The Chochet, a hastily manufactured automatic rifle, was crude, ugly, and prone to failure. American doughboys hated it. They called it the show, and often threw it away in favor of a standard rifle. Relying on foreign powers for critical armament was a strategic nightmare. If France fell, or if their factories were bombed, the American supply line would vanish instantly. The United States needed its own gun. It needed a weapon that could be mass-produced by the thousands, used by conscripts with minimal training, and fire continuously for hours without failure. And they needed it yesterday. The solution would not come from a massive government research facility or a committee of university professors. It would come from a modest brick workshop in Ogden, Utah, and the mind of a man born in 1855. John Moses Browning was a prodigy of mechanics. The son of a Mormon pioneer gunsmith, he built his first firearm at age 13 using scrap metal and patience. By his 20s, he was patenting designs that Winchester would buy and manufacture by the millions. He was the mind behind the lever-action rifles that tamed the West and the pump-action shotguns found in nearly every American farmhouse. But Browning was an outsider to the military establishment. He was a civilian, an inventor who worked by intuition and feel rather than by slide rule and calculus. He didn't draw blueprints. He made wooden models. He used his fingers to measure tolerances. He could look at a mechanism and simply see the forces at work. For years, the U.S. Ordnance Department had kept Browning at arm's length. They viewed his designs as too commercial, perhaps not military enough. They preferred weapons developed at the Springfield Armory, even if those weapons were inferior. Browning had actually conceived the principle of a recoil-operated machine gun back in 1889. The story goes that while out shooting with his brothers, he noticed the grass blowing violently every time a gun was fired. He realized that the wasted gas energy at the muzzle could be harnessed to cycle the action. He built a prototype using a lever-action rifle and a metal flap over the muzzle. It worked. He refined this idea into the Colt Browning Model 1895, but he knew he could do better. He knew the war in Europe demanded something heavier, steadier, and more reliable than the air-cooled potato digger. In early 1917, sensing the looming crisis, Browning went into his shop in Ogden. He was 62 years old. Most men his age were retiring. Browning was about to do the most important work of his life. He wasn't working for money, he had plenty. He was working because he saw the reports from the Somme and Verdun. He knew what American boys were walking into. He stripped the concept of the machine gun down to its absolute essentials. No wasted motion. No unnecessary springs. He wanted a machine that was as reliable as a hammer and just as tough. The engineering challenge of a heavy machine gun is a battle against physics, specifically heat and friction. When a cartridge fires, it generates temperatures exceeding 3,000 degrees Fahrenheit and pressures of 50,000 pounds per square inch. Doing this once is easy. Doing it 10 times a second, continuously, is an engineering nightmare. The primary enemy is heat expansion. As the barrel heats up, the metal expands. If it expands too much, the rifling wears out and the bullets start tumbling wildly. If the chamber gets too hot, a round can cook off, fire spontaneously without the trigger being pulled, creating a runaway gun that cannot be stopped until the ammunition is exhausted. Browning's design for the M1917 used a short recoil system. It was a masterpiece of timing. Here is how it worked. When the gun fired, the barrel and the bolt were locked together. They traveled backward together for just 5/8 of an inch. This brief travel gave the bullet enough time to leave the barrel and the pressure to drop to safe levels. Then, a cam block unlocked the bolt from the barrel. The barrel stopped, but the bolt kept moving backward, extracting the empty casing and compressing the recoil spring. The spring then pushed the bolt forward, stripping a fresh cartridge from the belt and chambering it. The genius was in the water jacket. Browning encased the barrel in a steel tube filled with 7 pints of water. As the barrel heated, the water boiled. The steam escaped through a hose into a condenser can, where it turned back into water to be reused. This evaporative cooling system meant the temperature of the barrel would never exceed 212 degrees Fahrenheit, the boiling point of water, as long as the jacket was kept full. But there were technical hurdles. The extractor, the claw that pulls the cartridge from the belt, had to be unbelievably strong. The German Maxim gun used a complex toggle lock system that was difficult to machine. Browning designed a simpler, vertical sliding block. Then there was the issue of headspace. Headspace is the distance between the face of the bolt and the stopping point of the cartridge in the chamber. If it's too tight, the gun won't close. If it's too loose, the cartridge case can rupture, blowing hot gas into the gunner's face. On most guns, adjusting headspace required a workshop and gauges. Browning designed the M1917 so that a soldier could adjust the headspace in the field using nothing but a screwdriver and the rim of a cartridge. He tested the prototypes relentlessly in Utah. He fired until the water boiled dry. He fired until the barrels were glowing red. He deliberately fed it dirty ammunition. If a part broke, he didn't just replace it, he redesigned it to be stronger. He wasn't trying to pass a test. He was trying to build a machine that could not fail. The demonstration in February 1917 was a success, but a prototype is not an army. The Ordnance Department officially adopted the M1917 in May 1917. They ordered 10,000 units immediately. Then the order increased to 40,000. But there was a problem, a massive problem. The blueprints didn't exist in a format suitable for mass production. Browning worked by hand. Now, the Colt Patent Firearms Company in Hartford, Connecticut, along with Westinghouse in East Pittsburgh and Remington in Ilion, New York, had to tool up to build these machines by the thousands. This was the scale-up crisis. You cannot simply hand a craftsman's model to a factory foreman and say, "Make this." Every single part, of which there were 137, needed detailed engineering drawings. Tolerances had to be specified to the thousandth of an inch, so that a bolt made in Pittsburgh would fit a receiver made in Hartford. The timeline was brutal. The first American troops, the Big Red One, arrived in France in June 1917. They had no American machine guns. They were training with wooden sticks painted black to simulate guns. Back in the States, the factories were frantic. Westinghouse, primarily a maker of air brakes and electrical equipment, had never built a machine gun before. They converted a massive factory in East Springfield, Massachusetts. They hired thousands of workers. Because so many men were enlisting, women flooded into the machine shops. They operated the lathes, the milling machines, and the stamping presses. The raw material shortage was acute. High-grade steel was in short supply. The chrome, vanadium steel required for the high-stress parts was being gobbled up by the naval shipyards. Westinghouse engineers had to fight for every ton of alloy. By August 1917, the tooling was still being finalized. The critics were loud. "Where are the guns?" the newspapers asked. Senators launched investigations. They accused the Ordnance Department of incompetence for waiting for the perfect Browning gun instead of buying more inferior foreign weapons. But the manufacturing giants were waking up. Westinghouse threw its best production engineers at the problem. They broke down the assembly into sub-operations. One worker did nothing but mill the extractor slot. Another did nothing but drill the sear pinhole. Production numbers began to climb. In early 1918, Westinghouse was producing 20 guns a day. By May, it was 100. By the summer of 1918, the combined output of Colt, Remington, and Westinghouse reached 5,000 guns per month. The workers in these factories were relentless. They worked 12-hour shifts, 6 days a week. At the Colt plant in Hartford, the noise was deafening, a symphony of drop forges and grinding wheels. They knew who they were building for. Many had sons or brothers in the trenches. The guns finally reached the front lines in significant numbers in late September 1918, just in time for the Meuse-Argonne Offensive, the largest battle in United States history. The real test wasn't in a muddy field in D.C. It was here, in the Argonne Forest, against the hardened veterans of the German Army. On September 26, 1918, the 79th Division launched an attack near Montfaucon. The terrain was a nightmare of bomb craters, barbed wire, and concrete pillboxes. Private Val Browning, now a lieutenant in the U.S. Army, was there to teach the troops how to use his father's gun. The performance was staggering. In one engagement, a company of the 315th Infantry was pinned down by German fire. They set up their M1917s. The water jackets hissed as the guns roared to life. The stability of the heavy tripod allowed the gunners to walk their fire with surgical precision. They suppressed the German MG-08s, cutting through the enemy positions. The reliability was the game changer. In the mud and filth of the trenches, where the French Chauchets were jamming every few rounds, the Brownings kept firing. One report from the 80th Division described a single M1917 firing 3,000 rounds in a continuous 20-minute engagement without a single stoppage. But the most legendary validation occurred involving a different Browning design, the M1918 BAR, which served alongside the M1917. However, the heavy M1917's moment of supreme glory came slightly later, during the holding actions. There is a documented account of a machine gun battalion during the Meuse-Argonne Offensive engaging in indirect fire, using the machine guns like artillery to rain bullets onto enemy supply lines over a hill. They fired continuously for 3 days. They fired over 100,000 rounds through a handful of guns. The crews worked in shifts, frantically refilling the water jackets from canteens, mud puddles, and even urine when the water ran out. The guns did not fail. German prisoners captured after these engagements were often terrified. They asked to see the automatic cannon that never stopped firing. They couldn't believe it was a standard caliber machine gun. The psychological impact was immense. The Germans knew the Maxim gun's limitations. They knew it had to stop to change barrels. The Browning M1917 just didn't stop. By November 1918, the American Expeditionary Force finally had fire superiority. The gamble to wait for the Browning design had paid off. By the time the armistice was signed on November 11, 1918, American industry had produced 56 M1917 machine guns. Of those, over 30,000 had reached France. It was a miracle of production, from a standing start to mass saturation in less than 18 months. The cost was substantial, but efficient. The government paid approximately $600 for each gun, about $12,500 in today's money. It was a bargain for the capability it provided. But the legacy of the M1917 extends far beyond the trenches of World War I. This wasn't just a wartime stopgap. It was the foundation of American automatic firepower for the next half-century. The basic design was so sound that it remained in service for decades. The M1917A1, a slightly modified version, was the backbone of defensive positions during World War II. At Guadalcanal in 1942, Marine John Basilone used M1917s to hold off a charge of 3,000 Japanese soldiers, earning the Medal of Honor. In the freezing hills of Korea in 1950, the water-cooled Brownings were still there, their jackets filled with antifreeze, cutting down waves of attacking troops. More importantly, the mechanism of the M1917 evolved. John Browning took the same short recoil principle and scaled it up to create the M250 caliber machine gun, the Meuse. The M2 is still in service today. It is the longest-serving weapon in the U.S. arsenal. From the turrets of Humvees in Iraq to the decks of aircraft carriers in the Pacific, the DNA of the 1917 design lives on. The M1917 also changed the American relationship with the military-industrial complex. It proved that civilian genius, coupled with mass manufacturing power, could outproduce the state-controlled arsenals of Europe. It established a model of cooperation between the inventor, the corporation, and the military that defines defense procurement to this day. Let's go back to Val Browning on that freezing day in February 1917. As he held down the trigger, he wasn't just firing a gun, he was validating his father's life work. John Moses Browning died in 1926 at his workbench, working on a new design. He never wore a uniform, yet he likely saved more American lives than any general in history. The irony of the story is palpable. The United States, a nation that prided itself on frontier marksmanship, entered the industrial age of warfare completely unarmed. It took a Mormon from Utah, working in a brick shop, to save the modern military from its own bureaucracy. The M1917 teaches us a profound lesson about innovation under pressure. When the crisis came, the solution didn't come from complexity. It came from simplicity. It came from a design that stripped away the unnecessary and focused purely on function. Every time you see a modern heavy machine gun mounted on a tank or hear the rhythmic thump of a .50 caliber on a firing range, you are witnessing the ghost of the M1917. You are seeing the mechanical legacy of 48 hours of desperate design and a father and son standing in a muddy field, proving that American ingenuity could answer the call when the world was on fire.